This lesson is part 2 of how to solve radical equations. And here we're going to look at how to solve radical equations when your result is a quadratic equation that you have to solve. So let's take a look at our 2 examples here. Our first example is x minus 5 equals the square root of x plus 7. We remember that our steps are the same steps that we discussed in the previous video of how to solve a radical equation. So let's first make sure our radical term is isolated, which it is because it's located right there on its own side of the equal sign. And then what we'll want to do is step 2. We'll want to do the principle of squaring. So I'm going to square the left side of the equation and then square the right side of the equation. When I do that on the left side, I'm left with a binomial squared. So I should square that binomial by either using the shortcut of how to do that, or I can just write out the binomial twice and use FOIL to multiply it. And on the right side of the equation, my square root symbol and my squared are opposite operations, so they cancel out. That leaves me with just the radicand of x plus 7. Now we're solving this equation. We get x squared minus 10x plus 25 when we multiply and simplify that multiplication problem. Just remember that we use FOIL and then combined like terms. Then we keep our x plus 7. So now that we've done this, we want to solve this equation, and we notice that what we have is a quadratic equation because I have an x squared term. So since it's an x squared term, I'll want to do my steps to solve a quadratic. We want to set this equal to 0. So I'll subtract x from both sides, and I'll simultaneously subtract 7 just to save a step. And when I do this, I'm left with x squared minus 11x plus 18. And that equals 0. And so if we remember our steps for how to solve a quadratic equation, we can either factor or use completing the square or use the quadratic equation. But I can see that this trinomial can be factored pretty easily. It's x minus 6 and x minus 9 and x minus 9 and x minus 2. And so from the principle of zero product, I know that my solutions are 9 and 2. So what we have to remember, though, is step 4 of how to solve a quadratic equation is you have to check the solutions in the original equation. So if I plug in my 9 to the original equation, I would get 9 minus 5 equals the square root of 9 plus 7. So that would be 4 equals the square root of 16. So that works. And then I plug in my other one, 2 minus 5 equals the square root of 2 plus 7. So negative 3 is equal to the square root of 9. And remember, that's the principal square root, so it's a positive. So negative 3 does not equal negative 3. So this is not one of my solutions. So there's only one solution, and that solution is x equals 9. I could put that in my solution set. Let's do one more example. We'll quickly move through this one. Again, we want to begin by isolating our radical term. Here's my radical term, which means I need to subtract 3 and move to the opposite side. So that leaves me with the square root of 27 minus 3x equals x minus 3. Now I'm ready to square. So I square the left side of the equation and the right side of the equation. And so I get 27 minus 3x is equal to, and I'll quickly do this binomial multiplication. I'll use the shortcut x squared minus 6x plus 9. We could have written that out and used FOIL, but we'll get that same trinomial. Now let's set it equal to 0. We'll add 3x on both sides. Again, now that I see that I have a quadratic equation, I know I need to solve this like I would solve any quadratic equation. So I'm going to set it equal to 0. So 0 is equal to x squared minus 3x minus 18. And now let's factor. Again, factoring is going to be the quickest way to solve this one because this is a fairly simple trinomial to factor. X minus 6 and x plus 3. So my possible solutions are 6 and negative 3. Let's just go back and check those into our original equation. So we begin with 3 is equal to the square, 3 plus the square root of 27 minus 3x, and we'll plug 6 in for x this time, and we say that that is going to equal 6, because that's what I'm plugging in for x. So I get 3 plus the square root of 9 is equal to 6. So 3 plus 3 equals 6. So x equals 6 is one of my solutions. That works. And let's plug in the negative 3. So 3 plus the square root of 27 minus 3 times negative 3 is equal to negative 3. So now we simplify that one. 3 plus, this is going to be the square root of 36 is equal to negative 3. So 3 plus 6 is equal to negative 3. So 9 equals negative 3. Well, that's false. So we know that x equals negative 3 is not a solution. So then our solution set is just 6.
The